The sun isn't just a blinding ball of fury, it's a magnetically chaotic superstar throwing occasional mood tantrums, leaving its mark in the form of sunspots. These dark spots might seem like tiny blemishes, but they pack a punch that affects everything from satellite communication to beautiful auroras. Let's dive into the video. What are sunspots? The sun's awkward adolescence. Sunspots are like the solar equivalent of teenage acne. They are temporary dark spots on the surface of the sun, photosphere, caused by concentrations of magnetic field flux that inhibit convection. The magnetic fields are so intense that they block the transport of heat from the interior of the sun to its surface, causing the regions to cool down to about 4,500 K compared to the surrounding 5,800 K, hence the spot. Think of them as patches where the sun's usual heat-relaxing routine goes awry. These magnetic disturbances can be so powerful that they create solar flares and C&Es, contributing to geomagnetic storms on Earth that can disrupt GPS and communication systems. The largest sunspot recorded so far spanned over 20,000 kilometers, large enough to engulf multiple Earths side by side. Sunspots and solar cycles, predicting the sun's tantrums. The sun follows an 11-year cycle known as a solar cycle, where sunspot numbers rise and fall. 2024 has been an interesting year for solar cycle 25. The peak number of sunspots for August was 215.5, surpassing the July peak of 196.5, marking the highest activity in solar cycle 25 so far. This surge in activity makes 2024 a major milestone in solar observations, with scientists eagerly watching to see if September will top this record. Sunspot numbers are crucial as they help predict space weather. The solar cycle progression is monitored closely by the Space Weather Prediction Center, which uses data from various international sources to predict solar maximums. These peaks can indicate increased potential for space weather events, which are critical to satellite operators and power grid managers. Why 2024 matters? A sunspot comeback. This year has been all about pushing limits. The solar activity witnessed in August is the highest since September 2001, during solar cycle 23. Solar activity took a somewhat calmer turn, but remained moderate, with 7 numbered active regions facing Earth. While August roared with solar drama, September played the role of the mellow sequel, still important, but less climactic. The big question everyone is asking: has solar cycle 25 reached its maximum, or is the best still yet to come? The current solar cycle prediction panel has noted that while we might see solar maximum around early 2025, surprises can happen. Fluctuations in solar activity are still possible, particularly in sunspot numbers, which could mean more coronal mass ejections and flares before the cycle starts its decline. How do sunspots affect Earth? Sun-sized side effects. Sunspots are not just eye candy for solar observers. Their effects can ripple out to affect us on Earth in surprising ways. The increased number of sunspots in 2024 means more solar flares, coronal mass ejections, and geomagnetic storms. In fact, the sudden coronal mass ejection on September 25 arrived earlier than expected, causing a G1, minor geomagnetic storm that brought beautiful auroral displays to North America. Such geomagnetic storms also pose risks to power grids and aircraft that operate at high latitudes. Airlines often have to reroute flights during heightened solar activity to avoid disruptions to communication and navigation systems, which was seen multiple times in 2024 as solar flares affected transpolar routes. Solar flares and coronal mass ejections. A cosmic fireworks show. Sunspot regions are typically the birthplaces of solar flares and coronal mass ejections, two highly energetic phenomena that can impact Earth's technology. In September, AAR 3828 was one of the most active regions, producing multiple M-class flares, which led to minor radio blackouts over different parts of the world. These flares are like solar fireworks, exciting but potentially disruptive, especially for communication and navigation systems here on Earth. Solar flares can disrupt high-frequency radio communications, particularly affecting marine and aviation sectors that rely on HF radio for contact across remote areas. The September 3 flare, rated M 3.3, caused notable HF radio blackouts across the Americas, highlighting how quickly solar activity can impact everyday technologies. The technology impact when sunspots play with our gadgets. The increase in sunspot numbers correlates with a rise in solar activity, which means more geomagnetic storms and more frequent radio blackouts. Satellite drag is one of the biggest challenges posed by these active periods. Increased solar radiation heats up Earth's atmosphere, making it expand and creating more drag on low Earth orbit satellites, potentially shortening their lifespan. This is particularly concerning for 2024 as the sun continues to approach its peak. Satellite operators like SpaceX and others have to account for these variations in drag and sometimes boost satellites to higher orbits to prevent premature re-entry. The increased solar activity has also been a concern for astronauts aboard the ISS, as heightened solar radiation means they must take extra precautions to limit exposure. The bright side of sunspots. A brilliant aurora. Not all sunspot effects are nuisances. They also bring the magic of auroras. This September, with geomagnetic storms flaring up due to coronal mass ejections, many regions in Scandinavia witnessed breathtaking displays of the aurora borealis. While we prepare for possible technology disruptions, the northern lights give us a colorful payoff for all that solar drama. Thanks, sunspots, for making our nights a little more enchanting. Scientists predict that as we move towards the peak of solar cycle 25, aurora watchers can expect more frequent displays, even in latitudes not usually graced by these spectacles. For instance, in late August 2024, auroras were spotted as far south as the United Kingdom due to a powerful geomagnetic storm driven by solar activity. Are sunspots a threat to humanity? Let's settle this. Is it time to worry about solar activity frying us alive or knocking us back to the Stone Age? Not quite. While powerful solar flares can disrupt power grids and communication networks, we are far from solar doom. The Solar Prediction Panel forecasted that solar cycle 25 would peak between November 2024 and March 2026, giving us a window to prepare for potential strong space weather events. So maybe less doomsday prepper and more watchful optimist is a good strategy for now. Sunspot regions. Who's making the waves in 2024? The most active sunspot regions of the year so far have been AR3807 and AR3813. In early September, AR3813 was particularly fiery, producing multiple M-class flares, including an M3.3 flare that resulted in a minor radio blackout across the Americas. These flares are an important indicator of just how intense the sun's magnetic fields can get, and for this year, the sun has been turning up the heat. With the number of sunspot regions increasing, scientists are closely observing the sun's behavior, as more active regions often correlate with higher solar flares and geomagnetic storms. This increased solar activity poses both opportunities and risks, offering beautiful auroral displays while challenging our communication systems and power grids. What lies ahead? The solar future. The Solar Cycle Prediction Panel anticipates that the peak of solar cycle 25 could come as late as March 2026, with a sunspot number potentially reaching as high as 125. This means we're in for more action-packed solar years ahead. Will the sun be gentler as we move into 2025? Or will it unleash even greater magnetic chaos? The uncertainty adds an exciting dimension for scientists, as they use a combination of machine learning models and past solar data to predict upcoming events. For now, all eyes are on the sun, and we're here, sunglasses on, ready to enjoy the show as the sun unleashes more surprises in its magnetic dance. Thanks for joining us on this journey through the fascinating world of sunspots. If you enjoyed this video, make sure to give this video a thumbs up and don't forget to subscribe to our channel for more future videos. Hit the bell icon so you don't miss out on our next adventure. Stay curious and keep looking up.